Hey, what's going on, guys? My name is Richard and welcome to another Python for Finance tutorial. Today the program we're going to be writing is one of my favorites, and you can see that scrolling down it's less than 60 lines of code. So make sure to watch the end of this video and of course leave a like down below if you enjoy it and subscribe to the channel if you haven't already. Now giving a quick overview of what this code will do, it'll basically automatically calculate and plot key pivot points and resistance areas during a stock's run. And let me show you a quick run through. You can see we've entered Tesla right here and it's output those key pivot points and also the date that they occur. And it will also plot them using matplotlib, and it will plot the stock's price history and also those key pivot points using horizontal lines. So definitely a very useful program because you could set alerts for when the stock's price basically runs through those key pivot areas. And going through the code, as I said, it's very short and also a pretty simple program. So today we're going to be writing that entire thing and I'll be explaining it step by step as I go. So now let's go ahead and start with kind of this bare bones program right here that basically forms the basis for all my Python for Finance programs. So first of all, we import the relevant libraries from Python, and we're going to need matplotlib this time, which we don't usually use. And make sure before you say that you get an error and something's not working, make sure that you've imported all of these correctly, because I get a lot of comments saying Yahoo Finance isn't working, and then half the time it seems like they didn't actually write this line of code. So make sure you import all of these correctly, and then you can see down here we actually activate that kind of workaround to make it work correctly, and we have our start date and end date for when we receive the stock's price data. And for me, I've started at 2019 just because I want to see the more relevant price data and pivot points. But obviously, you can set this back to 2010 if you wanted. And then we ask the user for a stock ticker symbol, and we have this bare bones while loop. All right, so now that we've got this bare bones code, let's start writing the meat of this program. And the first thing we're going to do is plot the stock's data normally just to make sure we can. And we're going to use the high data because we want to identify points that the stock hasn't been able to overcome. So it reached it and then got knocked back down. So df high.plot, and we're going to say label equals high. And then we've got to show the plot. So let's do plt.show and let's run this. So you can see we've imported matplotlib.pyplot as plt, and then we need to show that object. So going to our command prompt, we're going to say, we're going to exit out the example I just did, and let's go ahead and say tqqq. And there you go. There's the high data for the tqqq going back to the 1st of June. So everything's working correctly, and now let's go ahead and calculate those key pivot points. So let's go ahead and right here, we're going to say, first we're going to need a couple arrays. So we're going to have an array called pivots, an array called dates, and we're going to need a counter variable and also a variable called last pivot. So this pivots array right here is going to store the pivot values that we're going to calculate. The dates are going to store the corresponding dates for those pivots. Counter is going to count basically how many days have occurred since a maximum has happened. And this last pivot is just going to store the last pivot value. So before we go really further, I do want to say kind of what characterizes a pivot point for me, because that's definitely very important. So we're going to use this counter variable to count to 5. And that is because going to a plot or a regular stock chart, we want to identify a local maximum. And for me, I'm going to be using a period of 10 days. So we want to find a stock that is the local maximum within that 10 days. So it needs 5 days before to the left and 5 days after to the right. And that's what's going to characterize a pivot point for me. So on this graph, this would be a pivot point, this would be a pivot point, this would be a pivot point, and also right here. And you can see these are key lines of resistance. It wasn't able to overcome it right here, again, right here, right here, and of course right here. And then goodbye points are when it's broken through that line right here and right here. So that is kind of what a pivot point is for me, and that's important because we're going to have to codify that logic in this program. All right, so now we've got those variables. We're also going to create an array called range, and we're going to set that equal to 10 empty zeros. And this is going to be where we store the 10 period of days and their values. And we're also going to need a date range array with also 10 zeros in it. And what we're going to do is we're going to basically each day we're going to get rid of this value right here and then add on the next day. So we're always going to have a rotating window of 10 days. And now what we're going to do is going to say for I in df.index. There we go. And we're going to say the current max equals max of range. And we're also going to say default equals 0. So if there isn't a max, we're going to default this variable to 0. So what this is doing is for each time we run this program, it's going to find the current max of this array right here. Okay, so next we're going to need to get that most recent value. So we're going to say value equals round df high I, and we're going to round it to 2 decimal places. And next we're going to need is to cut that this array, get rid of that last value. So we're going to say range equals range 1 to 9. So it's only getting that this value to this value. And next we're going to say range dot append the most recent value that we got right here. And we're going to need to do this for the date array as well. So we're going to say date range and date range right here. And instead of the value, we're going to append the most recent date because it's going through each date and it's using that to iterate. So we can add that right away. So there we go, date range and the range. And next we're going to need an if statement, which is basically going to check whether or not the max stays the same, because if from one day it is this max and then the next day that's higher, that becomes a new maximum that we care about. So if current max equals max range, and we're also going to default equals 0, then what we're going to do is count one more. So counter plus equals 1. So we're going to keep track of how many days straight this current maximum is the relative maximum. Okay, so now we've got that. We're going to need an else. And if basically it becomes higher, we're going to set that counter back equal to 0 and look for another local maximum. And now we're going to need another if statement that basically checks if a pivot point has been found. So if counter equals 5, oh, didn't spell it right. And we're going to say, if this is the case, we're going to say the last pivot equals that current max. We're going to say the date location equals range dot index of that last pivot, and we're going to go get that corresponding date. So the last date equals date range of that date location. So I'll explain what this is in just a second after I finish writing this part. So after we get that pivot and that date, we're going to say pivots, didn't spell it right, pivots dot append last pivots, and also dates dot append that last date. Oh, there we go. Okay, so let me explain this block of code. So first, we're going to count to 5. So there basically needs to be 5 days lower on this side of this pivot, and then 5 days afterwards. So if that is the case, we're going to assign the last pivot to that current maximum, and we're going to need the date location of that maximum. So we go into this array right here and say that the maximum is right here. We need to go and get this index in this range because that index is going to correspond to the same date that we need to get so we can plot it on the graph. So that's what we're doing right here. We're getting that index in that array, and then we go get that last date. And then right here, we're appending that to both these arrays that are going to store that pivot value and also that pivot day. So everything's good. And let's go ahead and test this out for just to make sure there's no errors. So we're first going to have a print just to make it look nicer. And let's print out the pivots and also the indexes. So we're first going to need to, first thing we're going to need to do is convert the pivots array to an str so we can print it. And we're also going to need to convert the last dates to strings as well. So let's go ahead and run this and see if we made any errors. So let's quit out of this and run this tutorial. So let's enter Tesla once again. And you can see we have some errors. So in 23, last pivot is not defined. In line 23, oh, I forgot a 0 right here. And you can see I made another error right here. This should be in brackets. So let's go ahead and say these are brackets instead of parentheses because it is an array. So let's go, and hopefully this time it works well. There we go. So we've printed out the plot, no problem. And you can see we have a printed out list of all those pivot points and also those timestamps. So everything's working exactly how we planned. And now we need to clean it up a bit, make sure the user can use this to actually find those key pivot points. And of course, we have to plot the results on this graph. So let's clear the screen. And to do that, we got to X out of this. And we're going to say quit and CLS to just clear this, make it look nicer. Okay, so we have these arrays of pivots and dates. We're going to now iterate through those arrays and print them out in couples. So you can easily see this pivot was on this date and so on and so on. So we're going to need another for loop. So for index in range, and we're going to say the length of the pivots array. So this is going to basically iterate the number of times as number of pivots, which is also the number of dates. And now each time that it runs through this loop, we want to basically print out both the pivot point and also the corresponding day. So we're going to say in this loop, print str of the pivots index value. And we're also going to say plus, we're going to give a space here and print out the day that it occurred. So we're going to say plus again, and let's copy this value right here. And instead of pivots, we want the date. So dates and index. So that's all we need. And let's go ahead and give this a run one more time. Let's comment this out. I mean, you can do Control/ to quickly comment a block of text. And let's see if this works. So let's run the same program one more time. Let's give it Tesla. And there you go. We've got a nice list of the pivot value and the day that it occurred. So now all that's left with this program is to actually plot it on the graph. And this actually took a while of Googling and trying to figure out how to plot a horizontal line for just a specific amount of time. And I managed to figure it out. So let's go ahead and do that. All right, so first to do this, we're going to need a basically time delta variable, which is going to decide how long to plot that line for. So let's go ahead up here and call it time d for time delta. And we're going to say dt.time delta, and we're going to plot it for 30 days. And obviously you can change this based on your preferences. This is just kind of what I found to work pretty well, because usually the stock, if it's a kind of intermediate term pivot, will move up through this line before 30 days are up. So I found that to be a good number. And then down here, we're going to actually have to plot those values. So if you know how to plot a line, you basically need an X and Y coordinate and an X and Y coordinate. And for us, that Y coordinate is going to stay the same because it's a horizontal line, but we're going to use two different dates as our X values. So down here, we're going to need another PLT object, and it's a plot date object. So PLT dot plot underscore date. And first, we're going to list the X values, which is going to be in brackets, dates, index, and then comma, dates, index, and then we're going to add to this one that time D. So that is our X values, and then we're also going to need our Y values. So let's go ahead and enter just to make it look nicer, and we're going to now enter those Y values. So let's keep on going. So here we're going to say pivots index, and then it's going to be the exact same Y value as I said because it's a horizontal line. And then we need to close the brackets. And looks like I've made a mistake somewhere. So there we go. Okay. And then we need a parentheses. And now we're going to basically describe how that line is going to appear on the chart. So we're going to say line style equals dash for basically a solid line, and you could also do different things like this, and that just changes how the line appears. And you can Google line style to basically get all the different options, but we're going to stick with this solid line for this tutorial. And then we're also going to do line width equals 2, and we're going to say marker equals none. Okay. And marker equals none, I set that to none just because if you don't do it, it'll just show a huge dot right at that pivot point, which if you want that there, go ahead and delete this line. But otherwise, I think it looks a little bit nicer without a marker. And I think that's all we need to do. So let's go ahead and save this and run it one more time. So let's quit out of the past iteration and run this. So let's do Tesla. And you can see I've messed up a bit on the code. Okay, so my error was here. I need to add a bracket here and then also add a bracket right before those Y values. So that is what you need to change right there. And let's run it again. Tesla. And you can see, I guess I can't do none. Oh yeah, I had it like this. So this will be the equivalent of that none. So let's go ahead and run it one more time. And as I said, there's always going to be these errors. You just have to work with it and know how to Google your problems and use Stack Overflow. So let's do Tesla one more time. And there we go. We've got those nice lines identifying those pivot points. All right, so that is the final result. And you can see it worked out quite nicely. And you might be asking, how would I use this program to help my trading? Well, that's a good question. And probably the most logical thing that I would do is combine it with my email alert program and basically have Python send me an email whenever some of the key stocks that I like to watch pass through a prior pivot, because that means it's breaking through a prior resistance level and could be breaking out. And with Tesla, if you bought it right here and had that alert set, that's a nice gain that would allow you to hold through earnings. And let's exit out of this and enter Dexcom, which I think is also a really good example. You had a nice entry point right here. I think I got in right below here. And then once again, you have a nice entry point here, and you could add on when it breaks through this resistance level. And it just quickly allows you to identify those key pivot points and be ready to buy when it passes through them. So I hope you guys enjoy this program. I think this is probably my favorites that I made, especially because it incorporates actually plotting out a stock chart. So please, if you did enjoy, go ahead and leave a like down below. And if you're not yet subscribed to the channel, go ahead and do that as well. But other than that, thanks so much for watching, and I'll see you guys in future videos.